Does the mic work? Testing. Alright, the mic is working now. What I was saying. Welcome to the live stream, yo. It's 6:33. This is not what I planned. I planned it to. Let's turn up right. Yeah, I was planning to stream at 4 a.m. but shit happened. Broke my habit of waking up early, and it's the first day of the first year. Well, first time of the year 2022, which is pretty good. Feeling good about this. Okay. Let's not talk more. We're gonna be starting soon in like 5 minutes. Let me just meditate real quick. And then we begin our day. If you wanna join me in the meditation, you can feel free. Yo, a lot of technical issues today. That was meditation for the day. I might do it when I go to bed as well. But it's good. Don't want to break the streak that I'm on. Anyway, we can get started. Now. Oh, let's go. So I don't know what to do. Should I mute the mic? I probably would. I don't know. But this is like a webcast, so. Right, I'll put this here. Alright. So today's stream is about, well, study with me, but also on the topic of researching. Researching the field, the urinary incontinence. So I know, like I said, the whole story is I know a person who's struggling, like, who suffers from like a spinal cord injury, and then due to that, they can't know, they don't feel the urge when the bladder is full. So for us, when the bladder is full, we feel the urge to go to the pee, right? But for them, because of the spinal cord injury, which is, I think, in simple words, is disconnected, they don't feel the signals from the brain don't reach, or the signal from the bladder don't reach the brain. So, they don't feel the urge. And what happens is that when you don't feel the urge, you start leaking urine, which kind of gets in the way of life, degrades the way of life, and just brings the embarrassment factor, and just want to help that person out. So that is the stream. So what we're doing is like to help that person out, to prevent leakage. We want to like build a system that would be able to track how much urine there is. And in the past streams and offline, I've been kind of looking at how we can do this. Where I missed my application. Oh, I'm not. Yeah, how we can do this, and there's a lot of different ways. According, there's a lot of papers trying to solve this problem. It's an actual problem that people are trying to solve, and it's not a solved problem. It's not like a downloaded library, and it's an actual problem that people are actually trying to solve, and it's funny, and there's a lot of ways that people try to solve it. So, for example, they've tried to solve it using sensors. Like there are different various sensors, like ultrasound sensors, near infrared light sensors that you'll be able to attach to the person who's in the bladder of the person, and then the light would kind of go through the ultrasound and infrared, the absorption spectrum of these different forms of electromagnetic waves. You would be able to kind of tell how much urine there is in the bladder. But the thing is, we don't have such. I mean, we can build it, but it's like, come on, man. Can we try to do it in a more data sciencey way? Like, can we try to do it in a more data approach? And I found this paper, which is written by Pascal Venture, and they're from, I think, Germany, Bayreuth, Germany, which does exactly what I want to do. What I was thinking to do, but I'm not sure how effective that is. The thing they're trying to do is like build an app that would be able to track how much you drink and whatnot, but also they have this mathematical model behind how to model the urine in the bladder at any given minute after drinking a fluid. So yeah, I spent like the last 3 streams, kind of like trying to implement these, and I'm getting close, I think, to finishing implementation. But don't talk. Let's not talk about evaluation because I've yeah, I'm not. I've not reached there yet. But I'm just trying to implement the mathematical model behind their how they want to how they say uh, how they going about tracking the urine in the bladder, which is cool, yo. Where we got so far. Just a recap. I don't know. I do this every single fucking stream, but like there's so much code in it. Hold on, yo. I need to kind of like start my timer so I'll be tracking time. Not reflect. We can reflect in the break. Do some reflection from yesterday. What happened yesterday? Break. I'll put this down as research. And we can always change it later. 1 hour? Makes sense. Alright, so the stream, like study with me stream is kind of different. I'm like doing a webcast, but I don't know. But anyway, the whole point is you have some liquid in, right? And you have some output, right? Your input must be equal to your liquid taken must be equal to the liquid out, right? Liquid out, right? So what happens is when you take a liquid in, apparently in the paper they model it as like there's 3 different ways that could come out. One is 3 different ways, and let's call this L1, L2, L3. Okay. There are 3 different ways that can come out. So X is your input. That's the amount of original amount of liquid input you took. A glass of water. Okay. And now what we're looking at is like sum of I equals to 1 to I equals to like 3 Li must be equals to X. Okay. And now L1 refers to more of exercising, like amount of liquid lost, amount of fluid lost in when you exercise. Now this is hard to model, but what the paper has done over here is like I think they put it as a constant. I'm not sure you can see, but like depending on the intensity of experimental yada 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 yada. Yeah, depend. So they just have it as constant, which saves our life. But I'm not sure having it constant. Okay. Later. Depending on the intensity. Now that's a big range, 5 to 30 milliliters. I don't know how you would like where you would fall in that range, but that's a big ass range. Anyway, yeah, you could exercise, and then you have what was the workout next thing? Oh yeah, body storage, like the amount of fluid that gets stored in the body after you drink. So storage, which is like I don't know, like about like 0.4 milliliter or something like that per minute. Per minute. Which is not a amount, but it adds up quickly. And this one is the amount of L3. L3 refers to I don't even know what L3 refers to. Oh yeah, the bladder. The bladder volume. So amount of liquid that goes into bladder. Okay, and the interesting thing is, so we have this for exercise, it's 5 to 30 milliliters. For body storage, it's 0.4 milliliters per minute. Per bladder volume, it's actually they model it using a Gaussian function, the integral of Gaussian function. So if you have a Gaussian, right, like that. Okay, that's not a Gaussian, but you get my point. Imagine a bell curve, right? Um, mu is the time. Mu is the time after you. So time after time after. So there's some delay after you drank the fluid. That's some delay after you drank the fluid. Say at t equals 0, that's when you drank the fluid. And mu is some some delay after you drank the fluid, some time after. Okay, I think I may have said that enough times. And what happens is the proportion of fluid in your bladder increases accordingly to the integral, according to the area under the graph. So for example, if you were here, if the time was over here, right, then the amount of fluid in your bladder would be the area under the curve. Now, mind you, the area under the curve is 1. So we're talking about proportion here. So say if area was 0. I don't know, like 0.03, right? That means 3% of X has gone to the bladder, and so on, so on, so on. And one thing I was confused of was like, well, hey Sam, like what happens? For sure, if you just keep adding the area, you firstly you can't never, because it's a Gaussian curve, extend to infinity. So you can't be taking integral forever. What happens is like at one point, the sum of at one point this will satisfy. At one point this will satisfy, and then that's how you know when to stop. That's how you know that's when to stop. Okay. And in my code over here, I have modeled this particular logic, as a class, fluid event class, and so on, so on, and a fluid event handler to handle multiple events. So like if you have so this particular is a fluid event, right? It ends when that constraint is met. The sum constraint is met. So this is a fluid event. Oops. Fluid event, cool. And now there's an event handler, which if there's say multiple events, right, happening across different times, I don't know, say this is time and this axis, and then this is, I don't know what this could be. I don't know what this axis would refer to, but say this is time and this. All right, and you could have multiple fluid events occurring at different times, right? So and the important thing is how do we track the global from all, because you have to be more, right? Because these are fluid events, right? Each has a thing, right? So what event handler, the class that I'm writing, this class over here, event handler tries to do is it tracks the global amount of liquid lost to, basically it's just a fluid event that tracks at a global level, combines aggregated values of all the fluid events across different times. Hopefully that makes sense. So that was just a recap of what I was doing, and yeah, okay. Sure. Now what is next? I need to open my. By the way, I'll be streaming till 9, because I start work at 9. Um, it's work from home, guys, so like shouldn't matter. But I don't know how this is gonna go. Um, okay. What we're gonna do is put some. I wanna study with other people as well. It's more fun when you study with other people. So I'm gonna put some other study with me videos on my computer. This is what I really want to collab with other people one day, but looks like James is collabing with Helen. Sure, pretty cool. I like where this is going. Making the community stronger and shit like that. You know what I'm saying? Um, okay, because we are in the middle of a session 49. Okay, I don't even know where I was, but to be honest, I need to hold on. I need to open my log. Obsidian to find out where I was. Okay, delete search over here. I was here. Let's see. Not yet. Okay, I was. I remember now. It shouldn't be set to. Okay, there was a bug I was trying to fix. Oh, and I'll do that. So the bug I was trying to fix was shouldn't set current body storage, and let me. I need to see the code. Yada yada yada. It shouldn't set the current body storage and current workout loss to 0 because the water loss 0. Okay, fluid event right here. How we got? Okay, so yeah. Okay. I see where I was. Um, so if you, I think this graph explains where I was clearly. So what I was trying to implement was like, you know how the amount of urine in the bladder increases, right, over time, which makes sense. And the sharp fall you see over here is when the subject urinates. So they go to the toilet and pee, and the amount of urine in the system drops. And now the question is like, how do we make that happen? Obviously, we can set. Obviously, that main idea is to set it to 0. But like, when we set it to 0, what do we set it to 0? That's the main question. And can we do it correctly and not mess up the system we have? That is what I was trying to do. And let me just do that. Let me. Okay. Can I just think for a while? Right. I think I found what I need to fix, but I don't know how to fix it yet. Um, what we need to do over here now is um just up like this function over here, get total liquid loss from the fluid event class needs to this particular variable self current bladder filling um current bladder filling level needs to, if we can set it to 0 without setting them to 0, it should work. But I think there will be some other problems that would come because of that, and I'm not sure what other problems there will be, so I need to kind of think about this a bit more. Hold on. Okay, I think I have a better understanding of the problem now. The problem is that, like, the problem is, um, so if we want to pee, right, nutrition, if we want to pee, if you, um, then obviously you run this code, and when we run this code, it will set the current bladder feeling level to 0, which is exactly what we wanted, right? From the, which is exactly what we wanted, right? From on this particular code over here, what we just talked about in a second ago, we set that to 0, and we set that to 0. But the problem over here comes over here when, in the next round, when we go right, when we try to update the amount of um, fluid that was stored in the body, it depends on to get the total liquid loss. So we call this function again right? Get total liquid loss, and that's the function where what happens when we call this function is that this is set to 0, right? Which is not true. It's saying that the total amount of liquid gone to the bladder is 0, which is not true, right? The total amount of bladder gone to the okay, yeah. Yeah, I mean the total amount of bladder gone to the total amount of liquid gone to the bladder is not 0, um, but it appears 0, right? Because we just urinated. The amount of, I guess there should be two variables: the amount of liquid in the bladder, the amount of liquid in the bladder, um, and another variable called the total amount of liquid lost to the bladder. So there's bladder levels, the current bladder level, um, and the current bladder level and the amount of water lost to the bladder. Um, so yeah, I think that should kind of fix the problem. Oh, all right. Let me think a bit more on this. Actually, if we did make this, what would happen? Water lost to bladder. Question is, then who the fuck will update that shit? Yeah, I'm going circles around here. Yeah, for real. Um, and the stream is definitely making it harder, but I think I just need to get a habit of it. We can make it two variables. Yeah. Oh, I need to wake up. Yeah, hold on. Water lost to bladder. Yikes! Come on, Sam. Okay. Okay, let's try one solution that I have in mind. Um, for that we need to create one variable. So actually, can we? Okay, what do we name this? I'm kind of lagging over here. I don't know why, but okay. What was it? Bladder current bladder loss. Okay. Actually, I think I think it's better if we just put it here and then cool like that. Awesome. Awesome. Oh, I didn't mark it, so I need to. Oh, I should have marked the code. Now I have to like find where I was. It's ridiculous. Where was I? Where was I? Literally, literally, where was I? I think. Hold on. Here we go. I was here. Alright, let's mark this code before we lose it, so we can come back. Oops. What have we done? Shit, my caps lock is on. Uh, Here. Let's mark. How do you mark the code again? Hold on. It's been a while. Yeah, it's 7 a.m. Okay, hold on. Trying to code. It's not working too well. Okay, Vim mark. I keep forgetting Vim shortcuts. Some of the Vim shortcuts that I don't use too often, but which I find really helpful though. Yeah. Okay. Okay, cool. I got you, got you, got you. Okay. Yeah. Nice. Okay, current dude, this is literally a duplicate of current liquid law. Current bladder loss. Okay, that's cool. Okay. I think that's pretty much it, but we need to this function right here, get liquid loss. Can you please bring me to the definition? I want to go to the definition. Yeah, there you go. Instead, it should not be this, but in current bladder. Current. Oh god, I'm lagging. Thank you. Current bladder loss. Okay. I think it should work, but we need to test this. We really need to test this. Okay, migration happens. Let's go through the logic one more time. Yada yada yada. Current bladder loss. Okay. It's not happy about something. Really? Cool. It says my syntax is wrong. But where have I? Where have I fucked up? I don't know. We'll find out. The compiler would tell me. Okay. Um. Yada 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 yada. Okay. One thing we need to do is like in the fluid event history. Over here. Okay. This is basically a data class that holds thing bladder filling levels. So bladder loss. We can set this to like NP array. I don't know how scalable this is, but this is just an MVP we're trying to make. So I don't really care. Okay, I think, but it should be it should work. It should still work. Okay, which is really cool. We have that bladder loss. Oh, what's wrong? Unable to write. Yada yada yada. No space left on device. Holy shit! Really? Let's empty the bin. Give me a new computer, yo. Earl. Can you imagine how much junk there is in my computer? Like literally, I can't write a single letter, cause no, there's no space to write. Okay, we're good now. Compare. Alright, forget it. Overwrite it. Fluid event history, cool. Yada yada yada. We know that. I don't know where I've gone wrong here, but yeah, but I want you to update the event history. Body liquid loss, total liquid loss, total workout loss, total. Okay, basically it's literally just the solution is literally event history, bladder loss, and then we want to set event bladder history to we want to bladder loss. Bladder loss like that. Yo, what the hell? It's not fair. Okay, let me remove some application, yo. There's lots of junk. Hold on. I don't want to see. There's way too much junk in my. Shit. Oh, there's so many technical problems when I stream. It just takes away the like focus from my work. I think I'm gonna just like invest in like a tiny computer for streaming. No, like a second hand. I don't know, cause I don't want to go for M1. Like, no, those like bank breaker, yo. Anyway, please tell me we're good. Okay, for now. For now, we're good. Okay. Coolio. Where was I? See, I lost the train of thoughts. Okay, I was here. Event. Okay, we're just adding the new variable bladder loss to the event history. Event history is okay. What is event history? Event history is basically it tracks your data. It keeps track of what your bladder level was at any particular time. It's basically a list. It's basically a list storing the amount of fluid loss via particular arrow any given time. So basically, tracks L1 values over time and just stores it in the list. Yeah, that's event history. And now we just gotta add the new variable. So we just need to track a new variable called bladder loss, which is cool. We just did that. Now we just need, if not max yourself. Update current bladder loss. Huh. Are we taking T? Yeah, we're taking T, which is current event minutes. Okay, cool. Bladder filling. Interesting. Okay, so what is T? T is an int. It won't return us anything, but it would just update the thing. Look, I could make this into a big for loop, but like I said, but um, I could wrap. Okay, never mind. Never mind. Yeah, update that. Update that. So yeah, current bladder loss would keep going, will keep adding, but there'll be current bladder level, current filling level. The amount of liquid currently present in the bladder can reset. So that makes sense. Okay, that makes sense. That makes sense. That makes sense. Coolio, coolio, coolio. Update event history, metrician. Okay, shall we test this? Okay, how are we going to test this? That's a very good question. The user test I used to do, it was like, look at the graphs. Okay, it's not curved. It's not beautiful because it's like multiple fluid event being stacked on top of each other, so it looks kind of odd. But if you look at one, it should kind of look like this. I think the top one is the total liquid loss. All right, so how should we try? How should we test this? That's a very good question. Okay, does the script even run? Let me activate my environment. Let's activate this because I think we have a problem if we don't do this. Okay. Wait. Okay. Python event. Oh no, we want to run it as module. Which module are we in? Event dot. Oh, I don't like when your tab doesn't complete it for you. Yes. Okay. Cool. Line 158. Let's go to line 158. What's wrong here, sir? What is wrong? Invalid syntax, micro bull. Really? Okay, let me see what's going on here. Ah, okay. I think this is like that. Huh. That's odd. Is it that? Is it Nah, that's not that. Sure. Hey, what am I doing wrong here? Wait, is it really that? Nah, that's not that. I thought so. What am I doing wrong here? Ah, of course. Yes. Dude, what the hell, dude? Like, literally, I'm asleep. Like, wow. I can tell my mind is like, um, to the. Okay, it takes time. When you first run it. No, 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 no. Why is it taking so much time? Son, why are you taking so much time? Are you okay? Okay. Okay, 187.94. Actually, can we also track um event history dot bladder loss. Can we look at the last value? What's in the last value? Okay, my guess is that your bladder loss should be equal to your bladder filling levels if everything has gone right. Um, so what I'm trying to say, the first one, this one should be 100, and this one should be X, like some amount, right? I don't know. I don't know how much, but these two same should be same. Ooh, oh no, they're not. Something has gone wrong. It's interesting, which is good. Thank God I found out something is going wrong. Give me the bugs, yo. I like bugs. Bladder loss, self intake. Okay, what is going on here? I'm literally doing this. It's literally the same code, but am I not doing something? That is very interesting. 9287.84. Are we doing metrician anywhere? Oops. I'm not sure, man. I'm not sure. Okay. Tom T. Why are they different? Okay. The la bladder loss should be equal to your bladder filling level. Should, because we're not doing like we're not going to pee. So like, why are they different? Okay, I need to debug this. Hold on, there's a debugging. Let's go to debugging zone. Okay, current bladder filling level. Why are they different? Why are they different? So, current bladder loss. From okay, yeah. Okay, got you. Um, it seems that the ordering matters, but I don't know why the ordering would matter. So what I'm trying to say is like you have to call, you have to check your filling levels before you update. Or do you update and then check filling levels? I think that's just one of the reasons why shit happens is like, question is why. Now the question is why does the ordering matter? Uh, so this is the, okay, this is the wrong ordering. Okay, and this is the correct ordering. Okay. It's only when these two, the ordering's correct that, oh no, I think this is the wrong ordering. And this is the correct ordering. Okay, it's only when these happen that. Okay, yeah. Now, why? Why does the ordering matter? Wouldn't that be like one behind though? Let's take a. All right, let's take a break, yo. All right, let's take a break. I'm hella sleepy, yo. But we're really close to fixing this bug. Super close. We're super close. Like I said, I have to kind of head out. Well, not head out, but like, I don't think my computer will handle me streaming and trying to like Teams, like trying to use Teams. So I'm also watching James Salt's. Do I take notes? I take hella notes. But not like not as much as you would think. When I read papers, I take notes. Well, at least I try to like abstract it in a way that I understand it, and as far as I go. But there's plans that I want to turn those notes into videos and content for internet to consume. Because I think people will learn a lot. Because going through the paper takes a lot of time, and I feel like if I release the notes that I have on some few papers that I really liked, few research papers that I really liked, then I think it might actually help people out because they don't have to read the paper, or if they read the paper, they can just always like validate their understanding or validate my understanding, because I could be wrong, and I am most of the time wrong, and I don't know the answer to most of the things, which is quite nerve-wracking but also humbling at the same time. Yeah. I want to read a book. No one's here. Alright, yo. On to session. I think this might be the last one. Alright. This might be the last one before I actually head off to start my work. Um, Tomorrow will be kind of. Actually, we're gonna do this session for like 50 minutes. Not 59, but just 50 minutes. Yikes. Okay, let's get it started. Where were we? Okay. Where were we? Oh, yeah, we were trying to find out why the ordering actually matters because we need to find out why, otherwise, we're gonna have problems down the road. Now, yeah. Hmm. Not quite sure. The ordering, okay. Okay. Okay, I think I get it. I think I get why. I understand why we need to update the bladder filling level first, then we update the bladder loss. So what happens? Okay, so the reason why this is a wrong ordering and why that happens is like that. When we if we update the bladder loss, right? If we update the bladder loss, then the current bladder loss gets incremented, right? Um, because of this, this would be okay. So I think to not overcomplicate this, maybe I'll try to explain how I have thought in my brain, and then I'll try to simplify this further by just removing abstraction. So what I'm trying to say is like this function updates the current bladder loss, and when we run, when we run the bladder filling levels, what happens is like get total liquid loss is a bit higher. So what happens at the very end? This won't satisfy because get total liquid loss is dependent on the current bladder loss. So this one, run. So basically, it won't add. It will basically add 0. So there's few iteration where the bladder filling levels get added 0, which is not right, right? We want if bladder loss and bladder filling levels should increment at the same amount every single time. Unless there is someone who goes to pee. So okay, in a simple way, the way I understand it in a simple way is like we want these two functions to be independent, right? But if we update the bladder filling levels after bladder loss, it would not be independent. Actually, the bladder filling level will be dependent on the bladder loss. How would it be dependent? Well, because get liquid loss depends on current bladder loss. That reminds me of something. Because it's not only get. I don't know. Okay, maybe not. Okay, no. Okay, makes sense. Yeah, okay, yeah, it will be dependent because of this particular function. This particular function over here, um, get liquid loss, right? Has current bladder loss. So you can see how these functions are connected, right? How these two functions are connected. But if if this came first, right, then it would be independent of this particular function because we like I don't even know how to explain this, but yes, there's still a link between the variables, but man, can I just say it works? And I kind of briefly know why the ordering should be that way, and just move on. Let's add some. Okay, time to find the. Okay. Yeah, we gotta fit. Okay, should work, but let's see. Better filling level. Okay, shall we do 5 over here and bladder loss? in my head. No, no, no. Okay, but not saved it. Not saved it. Okay. I don't know what the bug was for, but okay. We'll see. There's one mistake as well. 1, 2, 2, 3, 4. Okay, yeah, that's exactly same what I want. Okay, now what happens is like, say on the 50th we do nutrition. Wonder what happened then. Say over here on the 50th, timestamp, we do. Is that possible to? Let's draw this graph actually, so that we can. No, 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 no. My head. A fluid event. Ah, ah, ah. Fucking caps lock. Like Vim and caps locks are like two dangerous things that you don't want to mix. Um, though can't be a lot. Julius. Okay. Okay, let's see. Event. Do we have event history? Yeah, we have event history object. Bladder loss. Yeah, give them everything. Total bladder. No. Okay, hopefully the graph should be prettier and more readable. Hopefully. Okay, yeah. Okay, that makes sense. So the second graph over here. Ooh, I'm lagging. So the second graph over here is the total liquid lost to the bladder. And the third graph over here is total bladder volume, the current amount of how much urine there is in your bladder currently. And the second one is similar, but like how much have you lost to how much of liquid has gone to bladder. So those are two different things, right? How much liquid there is versus how much you have, how much has gone to bladder. So I guess you can think it as of like how much, like say you have eaten food, right? How much of the eat, when you eat food, how much of the food is in your stomach currently, like live? How much is there versus how much of the food has have? Nah, that doesn't make sense. That analogy is pretty bad. no, okay, let's when you eat food, right? I know this is a sick analogy, okay? Not sick, but I think it gets the point across. When you eat food, how much of the energy from the food is in your body currently live? Okay? Versus how much of the energy from the food went to your body. So, a lot of fluid, a lot of amount of energy could have gone, like, when you eat a food, there you could have all the energy goes into your body, right? But only some gets at any particular time, only some, not all of them. Bro, this is ridiculous. I don't even know how to articulate this. If I had to articulate this to someone, they would get pretty mad. But I guess this is a practice, right, of me trying to articulate stuff. Yeah, but what I'm trying to say is, like, this over here is the bladder volume. It's talking about how much fluid is there currently in your bladder, and this is how much of liquid went. How much of total liquid went to your bladder? Yeah, it's almost like if you were okay. And then let's me create now another analogy. So it's like if you're in concert, how many people are there live currently in a concert, right? In a concert, versus how many people actually went there, right? So currently the number of people went there matches how many people there are in the concert. But this is not necessarily true, right? If everyone leaves at a certain point, say at 50, right, we can then this would kind of go to 0, but this would still be like 50, right? Because the total number of people when there would still 50, right? If that makes sense. Yeah. But that's good. At least I think that's a way better analogy, I think. So yeah. All right. Okay. So if we run this with when we go to P, like if we turn on the P mode, I call it P mode, then this should kind of go to 0. While I'm not sure what this would happen. Well, this should, I think, still stay the same. Okay, I predict that this top graph stay the same, but at 50, but at time t equals to 50, this just drops to 0. That's what I predict should happen. If it doesn't, then it's all good. Let's turn on the P mode. True. Oops. Let's turn on the P mode. And let's see what happens. Oh. What's going on? Alright, let's see what happened. What the hell happened? Okay, that's not right. But hopefully that's wrong graph. Oh no, shit. Oh no, hold on. Hold on. I think. Okay, this is. Let me think about this. Because it does what we want it to, right? But there's like a slight gradient, which is kind of. Interesting. Like, it should be like a straight drop, right? Like, if you go to P at a particular time, you release all the P at that particular time. Right? But we seem to have a slight gradient, and I don't seem to understand why there is a bump over here. It's basically saying it's not increasing. This particular time, it's not increasing. I'm not sure if this slight gradient is due to the graphing. Maybe there's spacing between. I don't know. I'll have to think. Hold on, guys. Give me. I need one moment to think about this. Guys, I managed to fuck it up big time. What the fuck is this crap? I don't understand. Uh, it seems to kind of go back in time. Like, increases. Pew. Yeah, I don't understand. I don't understand this. Hold on. What's actually going on? This is funny. Um, it's actually not that funny, to be honest. Okay. Does that fix the issue? And also, why is it finishing at 63? Time t equals to 63, which is concerning. Oh no. Okay, it's kind of back, but I'm not sure why. Uh, okay, let me check something. I think I can check something over here. Instead of printing out bladder filling loss, filling at check out like about like in the range of say 57. Oh no, 47 to like 52. All right, see what's happening over here. Ah, okay. Okay. It's actually correct. It's just wait, hold on. It's just that Why is it drop so? Okay, I think it's correct. It's just my graph. It's just the graph issues. But one concerning thing is like, why is t equals to 63? Why does the fluid event finish at time t equals 63, which is the concerning bit? Oh my god, I did not start my timer. Fuck. Anyway. Yeah, I need to know. Let me check something over here. T should not be 63. Should it? Yeah, T should be 50 to 55. I mean, no matter, like, yeah, T should be 55. Ah, yes, I get it. I get it. Because I did not update the. Is fluid event finished? No. Get total liquid loss. Ah, yes. Okay, I see. I see the problem. Um, huh. Maybe don't. I think what happens over here is when we do this, when we do this, say like that, when we do, it takes longer for the fluid event to be finished. It takes longer for the fluid event to be finished because I think because of the constant in the graph. So, so what you see over here is some constant, right? It's basically meaning like no fluid is being added to the system, which is ridiculous. So it takes a bit longer than expected, I think. So yeah, but the thing is, like, why is there a bump? Like, why is there a little bump over here? Why is the fluid event? So what? Okay, this little bump again. I think it means that across this time, the amount of volume in the bladder stays constant, right? No change. That means we're not adding to the system. But why? Yeah, that's an interesting point. I think that is why it takes longer. Where we are. Ah, yes, I get it. Yes, I get it, get it. Huh. It's because my if we have if when we turn on the P mode, right, which is called nutrition, if that's set to true, what happens is that we don't update any body storage, and so basically what I'm saying is this code won't run, so we won't be adding any fluid to the system, which is what happens, and I don't know if that's what you want, to be honest. I don't know. Um, maybe we want that. So we want to add to the. Yeah, I'm not sure, man. Okay, so in ideal scenario, I think Okay, I'm gonna just like briefly over here. So we want to add it to the body because if you pee, it doesn't matter if you're in this scenario, in this model. Like, if you pee, doesn't matter. If you pee, your peeing is independent of how much water. Your body will still store some water. And I'm assuming more, but yeah, and we can also do some water loss. Okay. Bladder filling. I think they do talk about this in the paper. So I'm not sure if this is what they mean, but like every fluid in the yada yada yada. So let's read the paper a bit. Okay, I think this is the point. Every time this is what happens when you turn on the P mode. This is what should happen. Every time you turn on the P mode, the bladder filling level resets to 0 milliliter. Okay, the filling level still increases after a P after nutrition in the case of. Okay, so you should still be adding stuff. Shouldn't make. Okay, account for natural kidney with limited maximum filling rate. Maximum filling rate. Okay, so correct order. So the bladder filling level would never go to 0. Okay, I'll have to try things out here. Okay, maybe we can do this. Really, I don't know. Okay, maybe let's try to do this. Nutrition is equals to. Okay, if nutrition is turned on. Come on, man. Come on, man. Come on, man. If that is turned on, then. Would you be happy then? All right, let's try to have a look. Let's try. Okay, it finishes at 55. Even no, I think I turned it off, didn't I? Oh no. Okay. Now, fucking no. Okay, look, nutrition is turned on, but it still finishes at 55, which makes sense. And if we look at the graph, oops, sorry. Okay, there's no bumps anymore. That's cool. That's good. Well, what we can see is like this is a bit wrong because it never goes to 0, which is not what we want. Okay, how do we make it to go to 0? Well, why doesn't it go to 0? That's a good question. Why doesn't it go to 0? I don't know, man. Fluid event. Why doesn't it go to 0? That's a very good question. After nutrition. Yeah, that's a very good question, yo. We set that to 0 and total liquid loss. Because we constantly add, right? We constantly add. Well, I think what should happen. Okay, let's try this. Okay, this I think this will just me playing around. Okay, whatever looks right, I think should be the answer. I think thinking too much causes problem over here. Okay, still finishes at 55. Total liquid output is 100. Let's look. Shut up and let's look at the. Okay, cool. It looks correct. It goes to 0 instead of 10. Cool. So if you put that thing in the middle, if you put the metrician in the middle, then it works. Enough fluid event. What if you put it at the bottom? The bottom. The bottom. A bottom. Got him. Got him. Okay. Cool. But does it go to 0? And it goes to 0 as well. Okay, so it looks like you can put it in the middle. You can put it in the middle, or you can put it in the bottom, which shouldn't affect. Maybe it does. I don't know. Huh. Okay, metrician definitely affects the variable, the current bladder filling level variable, right? And our question should be: is the current bladder filling level, the variable column, dependent? Is this function update current bladder loss dependent on current bladder filling level? Well, the answer is no. I think it doesn't use anywhere. Yeah. So we're good. We can put it anywhere, because it's not dependent, right? Metrician just affects one variable that is not dependent on to this function. So this function as a whole really doesn't care about like what metrician does. So we can, this function could be anywhere relative to bladder loss. So yeah. Yeah. But if we put it on the top, what happens is like metrician will set it to 0, but update current bladder would add it again for that timestamp, which is not what we want. I think let's put it here. Oh, okay. I think in the future I'll forget. I'll just write metrician is dependent. Date current is independent of metrician. Okay, cool. Cool. I think we've solved the problem. To be honest, I think that was. And this, we still got a few minutes. Like, I think we solved the problem of what we wanted to do today. Was to fix the. So yeah, it kind of models like, okay, look. When you start drinking water over here, nothing happens till like 40 minutes, really, and then it starts to go into bladder really quick, and then you feel the urge, you pee, which comes and so liquid in your bladder goes to 0. Well, we can, I don't know if that, but that's how the paper models it. It goes to 0 and then starts to increase again because the liquid is still being processed. Okay. Okay, we did it. We almost did it. We're like part way through this problem. Okay, part way through the sub problem, I would say. Okay, now we need to go event handler and instead of. Okay, we need to now. Well, at least we know fluid event is kind of tested, right? Pseudo tested. Well, I guess there's no test written for it, but Okay. Now, question is like, what do we do? Like, what kind of changes do we need to make? I have no idea what kind of changes do we need to make. Definitely first is, okay, let's me write that down, or else forget. Okay, our goal should be make changes to the event handler. The question now then, well, our goal is to make changes to the event handler. And the question now is like, what changes do we make? Oh, my tummy's rumbling, guys. It's not looking good. What changes do we make? Okay, firstly, I don't want the event handler to use audio. Hold on. I need to go loo real quick. Right. All right, yo, I'm back. Um, ooh, that was tough. All right, yo, I think that's. I'll stop it right here because I gotta. I think we solved the main problem. Um, which was. I'll cut. It's not 1 hour. I guess like. I know, but I'll try to stop it here for today. I don't want to make any more progress. I know the next step is to handle the fluid event handler. This particular to kind of adjust to what we just fixed. And that is pretty. And yeah, that should be in the next stream. And after that, I haven't thought much, but we can think about it next stream. What's next? How are we gonna turn this into a API? How are we gonna create an API using what we have written? But actually, I need to put this into GitHub because we made some progress. What's the commit message? Let's say okay, fixed fluid event class. Well, I didn't fix it. Well, fix the fluid event class to handle metrician. Okay, let's push this. Let's push this to GitHub. I'm working on the master branch. This repo is public, so if you go to my GitHub profile, you should be able to find the code. Pager07, it's right here. Urinary incontinence. Anyway, yeah, that's it for today. I don't want to start. I have a meeting in 5 minutes because it's 9. We'll start at like 9. Well, not 5 minutes, 10 minutes. Which was good. We chunk. Which was good. I guess today's stream was a bit productive. Yeah. Gonna do some DS work now. It's pretty fun. I'm also watching James while I do this, so it's actually fun to watch him. James and Alan, right here. It's kind of fun to collaborate. I mean, it was kind of fun to have them on and the stream as well. I don't know. Anyway, let's put them aside. But my computer doesn't like it for sure. I can tell. When I put them on, James and Alan. Yeah. Well, that's it for today. The plan for today is after this. Actually, I think I might just cut it off in a minute now because I need to kind of like reflect, do some reflection on what happened yesterday. Track my study time and see if I'm making progress and stuff like that. But yeah, thanks for. Well, no one came in, but that was really fun. Midway through the book as well. Well, not midway, just started. It's really good. So yeah, tomorrow we're gonna fix event handler, the fluid event handler, and I can't wait for the step where we actually build an app. I don't know how to build an app, but but I think we'll be fine. Using databases, building an app. It's been long. As a data scientist, you don't actually do much of that. It's more of software engineering. But for this project, I'll have to lift all the weights from all different departments. Because yeah. All right. Anyway, that's it for the stream. It's 2 minutes in. Like, I just want to stay here for 2 minutes so that, like, I don't. I don't, so that I don't kind of like say what my stream is, because my stream, I think the title is like 60 to 10, right? So let's just sit here for like 60 minutes and just talk about shit. Um, well, well, maybe I can show you a bit on like my reflection period, how I do it, which I find really helpful, to be honest. I'm quite sleepy as well. All right. First thing is first. You gotta, when you open a new tab, you may have to make it quick and easy to access it. If it's not quick and easy, then the more difficult you make, the less I do it. That's the pattern I noticed in myself, and it's validated by a lot of books I read as well. So it's quick and easy. This is like August. It's pretty old. It's outdated, to be honest. This, okay, my computer doesn't like it when I open Excel. I have no idea why though. Why don't you like it when you open Excel? Excel. I hope you go to hell. Excel. Oh shit. Excel. Excel. Like Excel hair. Excel. Nexel. Oh shit. Biology, like no. Nexel. Or like a battery. Nexel. Or like a telephone, like a Nexel. So, wow, so like there's like a triple meaning over here. I could, if I had to write a rap, then it's probably a really sick line. Anyway, yeah, I'm still in a mode of like making it, but making my basically I've refined my tracker for this year a bit differently, so that I have a graphs and dashboard I can look at and see if I'm making progress. But this looks like the computer won't handle it right now because it's too. Maybe I can show you guys next time. All right. Maybe I can show the stream next time. When I say show you guys, it's kind of weird because there's no one watching. But okay. It's funny. It's funny. Funny. All right. Oh, that's it, guys. I'm out. I'll see you guys tomorrow. Tomorrow 4 a.m. Hopefully, if I wake up at 4 a.m., it'll be longer. But ciao, guys.